Assalamualaikum warahmatullahi wabarakatuh. This video is for ECM 366 Civil Engineering Quantities and Estimation, and this video is still for the measurement of earthwork. In previous video we have learned on grid method, and for this video we are going to do for the cross section method. The cross-section method involves plotting cross-section of the existing and proposed level at regular intervals across the project site. The volume between each pair of section is estimated by multiplying the average cut or fill area of the two sections by the distance between them. Normally, for the cross-section method, we will apply for elements that have the same cross-section. For example, here we have a roadwork, and if we notice, the cross-section of the road will be the same along the road, whereby the cross-section is like a trapezium. And if you notice, along of this road, the cross-section will be the same. The same thing for the canals here. It will have the same cross-section along of this canal. So at any point of the canals, if you cut, it will have the same cross-section. Next, we look at the formula for the cross-section method. So here, let's say for example we have an embankment with the breadth B, the depth is D, and the slope value is S, the length is L. So first formula is for the surface area. The surface area is this area, and you can calculate the area here by using this formula. So surface area equal to BD plus SD squared. Next, we have the formula for the volume. Volume means that we are going to calculate amount of soil that we need to have so that we can have this embankment. So the formula is volume is B the average plus S the average squared times with L. Next, we have side slope. Side slope is basically the length at the side. So the side slope is given by the equation D times S squared plus 1, and then you square root. And the last one is area to be turf. So this is the area to be turf. Basically, area to be turf is the slope that we need to protect for the stability. In normal practice, maybe we can plant the grass or we can cover with concrete so that this area is stable and to avoid from landslide. So the formula is given by D average times S squared plus 1, and then you square root and multiply with 2L. The reason for 2 here is because you have two sides. The first one you have this side, one side. Another one you will have on the other side. So that's why you multiply with 2. So this one is for the simple shape trapezium for the embankment. Let's say we have a more complex shape for the embankment here. Let's say the depth is different, whereby at this side the depth is D1 and this side is D2, and then at the back there the depth is D3, and at this side is D4. Let's say D1, D2, D3 and D4, the value is not equal, the value is different. So how to get the surface area? Right, so for the front, we can set here is as a chainage 0, 0, and at the back there we can say it is as chainage L, because the length here is L. Right, so for the surface area at the chainage 0, 0, surface area at chainage 0, 0, meaning that this area. So the formula is surface area equal to BD average plus SD average squared. So given that D average equal to, for the chainage 0, 0, you have D1 and D2. So D average equal to D1 plus D2 and divide by 2. So after you get D average, you just substitute back inside of this formula. So that is the surface area at chainage 0, 0. And then you will have surface area at chainage L. So meaning that surface area at this chainage. So the same formula, surface area equal to B D average plus S D average squared. So given that D average for chainage L equal to D3 plus D4 and divide by 2. So after you get the value for the D average, you just substitute back in the equation here. So you will get surface area at chainage 0, 0 and surface area at chainage L. So the value for the surface area will be different for chainage 0, 0 and chainage L. Next, for same example, we have a different value of depth here, D1, D2, D3 and D4. Just now we learned how to get the surface area for chainage 0, 0 and chainage L. Next, we are going to determine the volume. So here the formula will be quite different, whereby the volume equal to surface area at chainage 0, 0 plus surface area at chainage L, and then you divide by 2 and then you multiply with L, right? Or in a simple formula, it can be surface area average multiply with L. So for example here, after you calculate the surface area at chainage 0, 0, you then use plus with the surface area at the chainage L, you divide with 2 to get the average, and then you multiply with L, so you will get the volume. Right, so that's it for the volume. Right, so let's put back the value of the depth here, D1, D2, D3 and D4. Okay, next for the side slope, let's say you want to measure the side slope here, so it will be side slope equal to d1 multiply with s squared plus 1 and then you square root. So this one is for this side. For this side it will be different. So side slope here equal to side slope equal to d2 times s squared plus 1 and you square root. For the last one, area to be turf, so let's say this is d1, d2, d3 and d4. First, for this area to be turf, for this one, so the formula will be area to be turf equal to d average multiply with s squared plus 1, then you square root, and then you just multiply with L, right? Because please take note that this side will be no longer equal to this side, so you need to calculate separately. So that's why here it will be only L, not the 2L here. Okay, so for this one, the D average will be D2 and D4. D2 plus D4 divided by 2. So you will get the surface area to be turf for this side. Okay, so for the other side, D1, D2, D3 and D4. So let's say for the other side, this side, the area to be turf, equal to D average multiply with s squared plus 1 and then you square root and also multiply with L. Okay, and then here the D average, it will be D1 and D3. So D1 plus D3 divided by 2. So after you have calculated this one, you substitute inside the formula. So you will get the area to be turf for this side. Okay, so next we proceed to the exercise. So we look at exercise 5. Figure 5 shows a 100-meter long of road. Okay, so meaning that the length of the road here, it will be 100 meter. So that's why here there is chainage 00, and at the back there it will be chainage 100, because the length, total length of the road is 100 meter. On a uniform ground, the width of formation is 10 meter. So this is the width, ataupun or the symbol that we use is breadth B, and the side slope is 3,1. Right, so the 3 here, it referring to the S. So the value of S equal to 3 for this question. The height of the embankment at Change 00 and Change 100 are 1 meter. So here the depth is 1 meter. And at Change 100, the depth will be 1.5 meter. Calculate the quantity of earth to be filled and total area to be turf for the road. Right, so we look at the solution. First, we are going to determine the volume to be filled. So because the area at surface area at Change 00 will not the same with the surface area at Change 100. So meaning that you need to determine the average surface area in order for you to determine the volume. So first you need to determine the surface area at Change 00. So apply the formula BD plus SD squared. So here no need to use the D average because the depth at Change 00 is equal to 1 meter. So if you calculate the average also you will get 1 meter, so no need for you to calculate the average. So B equal to 10, your D is 1, S is 3 and your D is 1, so you square, so you will get surface area for Change 00 is 13 square meter. And then for Change 100, the surface area, you apply the same formula BD plus SD squared. So the B is the same 10, but the value of D will be different. For Change 100, the value of D will be 1.5. Value of S is similar 3 and value of D is 1.5. So for Change 100 surface area you will get 21.75 square meter. So after that you need to determine the average of surface area, meaning that you need to sum up the value of surface area for A1, use plus with surface area for Change 100, and then you divide by 2. You will get the average surface area, and you just multiply with the length, which is 100. Right, so average area you take 13 for Change 00 and 21.75 for Change 100. You divide by 2, you will get the average, and this one is the length. So the volume for this road is 1737.5 cubic meter. Next, we are going to solve for area to be turf. So meaning that you need to determine the area here. Okay, so based on this figure, we know that the area to be turf here at this side will be the same with the other side. Okay, so if when we know it's the same, so when we are going to apply the formula, we just calculate at the same time. So we just put 2L. So we look at the solution. Okay, so here area to be turf, the formula is D average plus S squared plus 1 multiply with 2L. So here it used 2L because we know the area at both sides will be similar, so we calculate at one time. So D average, we take 1 at Change 00 and 1.5 at Change 100, we divide by 2 to get the D average, and 3 is the value of S squared plus 1, and then times 2 because both sides will be the same, and L equal to 100. So after you calculate, you will get 790.57 square meter. So therefore the quantity of earth to be filled, as we calculated at the top, it will be 1737.5 cubic meter, and then total area to be turfed, it will be 790.57 square meter. So that's all for the cross section method, and I hope all the students can understand, and I hope you can memorize all the formula to calculate and when you apply the cross section method. So that's all for this video. Thank you very much.